Hi, my name is Ibrahim Mohammad Musa. I go by Musa. I'm going to present my paper, Does Transliteration Help Multilingual Language Modeling? It's a work from last, yeah, speak closer. Okay, it's a work from last year and it got published to ESL. So yeah. So the motivation is like there are a lot of low resource languages in the world that our recent language models can't deal that well. So we always have to think about how to make those models perform better on low resource languages. We have to figure out what issues are there that are specific to those low resource languages. So here in this particular paper, we focus on one particular issue. There's that a lot of languages, particularly from South Asia, like India, use different writing scripts, which leads to a problem of like poor lexical overlap among closely related languages. And that leads to poor tokenization. Like if you have a fixed number of tokens in your model, then you have, because all these languages are using different writing scripts, uh, you'll your tokenization budget will be split between different languages. So yeah, there are some solutions to this. Like one is to like convert everything to like some IPA transliteration, IPA format. Like you convert it to pronunciation. You don't deal with writing scripts anymore. Another solution is to do transliteration, where you convert all these different writing scripts to say like Latin, and then you train your model. Yeah, so for the benefits of transliteration is you can call out multiple different writing scripts to one single script. For example, here we show 9 languages from like India, each of them using like different writing scripts, but once you transliterate them to Latin, the word is parrot here, and it gets mapped to just one single token in Latin. So there's the intuition, and then all these different words in 9 different languages will get mapped to one word, and that's the idea that it will improve lexical overlap. Okay, last. Yeah. So, so our in this paper, we just want to see if we transliterate to the transliteration, will this improve the performance of our language models, and if it is statistically significant, and if our models will learn better representations. So we did a preliminary study where we see like if our tokenizers are better. So we see that the average number of tokens per word is lower when you use the transliteration. That means like words are getting split less, and that's what is shown on the right side. Like now a ratio of word that is unbroken by the tokenizer. Like we can see like for the left side, the Punjabi, like 80% of the words are not broken down if you do the transliteration. So once we see that like our intuition works, then we train like BART models. Basically, we pre-train BART models, one on original corpus, one on transliterated corpus, and finally we evaluate on a diverse data set, which was IntiGlue, and then we use some statistical significance testing, and finally we'll do some similar representation similarity analysis. So here are the results. So the most important part is, if you see on the left side, named entity recognition, you'll see that the difference, like our transliteration model, which is shown by US, basically Uniscript, the performance difference is like almost 12%. And that's for a low resource language, Punjabi. And there is also another one, AS, this Assamia, and you also see that in the low, like just 13.61% for the Albert model. So we can see that for low resource languages, the performance improvement is a lot better, so which is promising. And yeah, and also if you look at the other languages, like it is almost always, for almost all languages, the performance gets better. So our idea doesn't hurt the high resource languages. So yeah, and this is some other results, and this is, and then we finally do some representation similarity analysis with CKA. So we measure similarity of for a translation data set for parallel sentences across different languages. And we can see that for our Uniscript models that are using transliteration, the embeddings get higher similarity score for different languages. So that means that the models are learning representations that are more similar across different languages. And if you see that, like, we calculate representation for different layers of the models, and you can see that for the later layers, the representation scores, similarity scores are higher, so which indicates that the models are learning better semantic representations. Yeah, that's my paper. Thanks for listening. I'll take some questions if you have. Thank you.
Hi, thank you for the talk. So does what you're transliterating into matter? So does it change the results, whether you're transliterating into, like, if you're Romanizing versus you're transliterating everything into Devanagari script, or everything into like the Bengali script, or everything into like the Telugu script?
Yeah. So the reason we chose Latin is because, like, we initially was trying to do it with Devanagari, but then we saw that, like, if we do it transliterate it to Latin, then it's the process. Like, you can easily get back from Latin to the original script with lower errors. Like, these transliteration processes are not exactly error-free, so you can't always get back the original text. But with Latin, we get the most of the original text back. That's why we finally chose the Latin here. Yeah.
Okay, but for downstream results, I guess maybe you haven't actually tried anything but
No,
Latin
because
at this
we are
point.
pre-training models here, and it's really expensive.
All right.
So yeah, we just did one. Yeah.
All right. Thank you.
Yeah.
All right. Actually, had a follow-up question on
Yeah.
the scripts as well. You said there's some loss when going back from the Latin script to
Yeah.
the original scripts, and
Yeah.
it seemed to be the best one to recover the original text.
Yeah.
It seemed like you had some like diacritics. So on the A, you had like a flat line for long A's, and for on the like a retroflex S, you had like accent marks. So that's like an extended Latin set. Is there a benefit to using maybe IPA specifically that can represent sounds from different languages?
Yeah. This one is we're using the ISO 19121 standard. So this is like a standard like developed by the some international organization. And we have like Python implementation for that. So that's why I use this one. But alternatively, we could have used the IPA one. Some papers also do that. But then the token overlap, because the pronunciations, even though the words are written the same way, but the pronunciations may not be same. So then our idea is to increase the lexical overlap. That doesn't fully apply there. That's why you chose the one that like maximizes the lexical overlap.
Okay, that makes sense. Thank you.
Thank you.
Let's thank our speaker one more time.
Thank you.